screw instructional video. Constant technology advancements have made people's lives convenient and comfortable. Everywhere in our daily lives, we can notice the effects of technologies that are derived from little inventions that lead to major advances. Transmission is one of them. Linear motion. What is linear motion? In a nutshell, it consists of moving an object from one place to another via linear movement. There are countless transmission products employing linear motion. Even if you don't fully understand the principle of transmission, you are certainly using it in your daily life. Furthermore, this principle is used in many kinds of machinery, which are used to produce other technology products that we also use in our everyday lives. The first attempt to place ball bearings between a nut and screw, replacing sliding friction with rolling friction, was made in 1898. Ball screws were applied to automotive steering systems in the 1940s, and subsequently were used in many kinds of industries, including the machine tool and semiconductor industries. Ball screws are composed of screws, nuts, a recirculation system, and ball bearings. They are low-friction transmission elements that can be used to convert rotational motion to linear motion, or to convert torque to axial reciprocating action. There are three types of ball screws, which differ in how their ball bearings circulate. External circulation ball screws, internal circulation ball screws, and end cap circulation ball screws. External circulation ball screws consist of a screw, nuts, ball bearings, return tube, fixture block, and wipers. The bearings are located between the screw and the nut, and circulation is achieved using return tube. As a result, the bearings return by way of the nut. Since the return tubes are located outside of the nut, this is known as an external circulation ball screw. Return tube. The bearings return via the return tube, which ensure that the bearings travel along a sealed circuit. The fixture block is used to anchor the elbows. Wipers. The wipers are located at the outer ends of the nuts and serve to ensure a good seal. They prevent dust and cuttings from entering the bearing circuit. Internal circulation ball screws are composed of a screw, nuts, ball bearings, return caps, and wipers. The bearings circulate in single circles. The return cap spans two adjacent bearing races, forming a single closed circuit. Because the return cap is installed within the nut, this type of ball screw is known as an internal circulation ball screw. Return cap forms a return channel for the bearings and ensures that the movement of the bearings follows a closed circuit. End cap circulation ball screws are composed of a screw, nut, ball bearings, and end caps. The bearings remain between the screw and the nut, and the bearings return via a hole made through the end cap and the nut. Because this ball screw design causes the steel bearings to pass through the front and back sections of the nut, it is known as an end cap circulation ball screw. Now we will introduce the contact geometry of ball screws. Pitch circle diameter is the diameter of the circle formed by the central diameter of ball screws' upper and lower ball bearings. The lead is the distance traveled by the nut when the screw turns one rotation. The bearing ball diameter. The root diameter is the smallest diameter of the threads. The outer diameter is also known as the nominal outer diameter and is the largest diameter of the threads. A Gothic arch tooth design has two identical radii and an offset center. Basic dynamic load rating. What is the basic dynamic load rating? Let's use an example to explain this concept. Suppose 100 runners are carrying heavy objects in a marathon, and they run the 1 million laps around the track at the same speed. In this marathon, at least 90 athletes must complete the full race, and fewer than 10 persons can drop out. The weight that everyone is carrying is termed the basic dynamic load rating. The basic dynamic load rating is therefore defined as follows. After a batch of ball screws with identical specifications have completed 1 million movements, the maximum axial load ensuring that the thread tracks or bearing surfaces on 90% of the ball screws have no fatigue, damage, erosion, or pitting. Basic static load rating. Let's illustrate this with a simple example. Suppose an athlete at a weightlifting competition gradually increases the weight on his barbell. The more the weight increases, the more the weightlifter's arms flex. If the length of the person's uplifted arms is L0, and the length of his arms after lifting the barbell is L, when L0 minus L equals 1/10,000th, we call the weight the basic static load rating. The basic static load rating is therefore defined as follows. When the ball screw is in a static condition, the axial load is such that the maximum plastic deformation of the bearings and the contact surface of the ball race does not exceed 1/10,000th of the bearing diameter. Preload and backlash. This can be explained using a simple example. When a thin person gets into a car, because there is empty space both in front and behind that person, there is no preload, but there is backlash. As a result, if the car brakes or accelerates suddenly, this thin person's head will bump around in the car. In contrast, a larger person that cannot enter the car and has to be pushed in by other people fills the entire interior space, which means there is preload but no backlash. If the car brakes or accelerates suddenly, the larger person will not bump around in the car. Similarly, in the case of a ball screw, when the bearings are relatively small, because backlash exists, the nut will tend to vibrate back and forth as it performs its reciprocating motion. In contrast, when the bearings have a relatively large diameter, there will not be any backlash, and preload will exist. In this case, there will be no vibration. Rigidity. Let's use another example. When a person leaps onto an empty bus, the bus will experience severe rocking. In contrast, when a person leaps onto another bus that already contains 30 passengers, the bus will not rock much at all. The use of slightly larger bearings in a ball screw will create preload, ensuring greater rigidity. The use of smaller bearings will reduce the amount of preload, and rigidity will also decrease. When ball screws are subject to the same external force Fn, the relative displacement of the nut and screw in the ball screw with greater rigidity is relatively small. Relative displacement of the nut and screw in the ball screw with less rigidity is relatively large. Positioning accuracy. We will first introduce the concept of lead. Lead is the distance traveled by the nut when the screw turns one rotation. Loss of positioning accuracy may be caused by small differences in the lead due to manufacturing error. When the screw rotates 10 times, the displacement of the nut will not actually be exactly equivalent to 10 times the lead. Nut processing. Coarse turning. Boring. Thread turning. Milling race, the most important process in nut manufacturing. External grinding. Internal thread grinding. Screw processing. Thread turning. Heat treatment. Shoulder turning. External grinding. Internal grinding. Assembly. Although the structure looks simple, the difficult part of manufacturing ball screws is that mechanical processing must be accurate to within a micron. Ball screws are currently used in an extremely wide range of applications, including CNC machinery, precision machine tools, all types of industrial machinery and equipment, and the electronics, conveyor equipment, and aerospace industries. They can be found in many applications closely connected with everyday life. Ball screws have undergone many improvements and innovations since they were first commercialized, and today many different types have been developed. Heavy-duty ball screws must withstand high axial loads and are used in all-electric injection machines, stamping machines, semiconductor manufacturing equipment, and forging machines. High-speed ball screws have a high-speed velocity and high acceleration. They must be highly rigid and have low noise and vibration. They are used in fast feeds for machine tools, high-speed mold cutting center machines, and high-speed general cutting center machines. Cooled ball screws. A cooling liquid is forced through the center of the nut, removing the heat produced when the ball screw is operating at high speeds and reducing thermal expansion. This enables the ball screw to maintain a high level of accuracy when running at a high speed. They are used in high-speed machine tools and high-speed general processing center machines. Rotating nut ball screws integrate the bearing nut with a supporting bearing, enabling rotating and linear motion. These ball screws are used in semiconductor machinery, industrial robots, woodworking machines, laser processing machines, and conveyor devices. Self-lubricating ball screws have a detachable oil storage device and require no lubricant tubing systems or equipment. These ball screws can reduce oil replacement and disposal costs. Silent ball screws have specially designed bearing spacer rings separating their ball bearings. This not only prevents the noise caused by impacts between bearings, but also prevents the mutual friction and wear of the balls, ensuring smoother and quieter operation. In contrast with ground ball screws, roller ball screws are produced by using rollers to create the threads in the screw surface. They are then subjected to heat treatment, polished and assembled. These ball screws are easy to produce, reasonably priced, and can be shipped quickly. Little inventions that lead to major advances. Ball screws.